Hello, welcome to De La Cruz Engineering videos. So in this video, we'll be solving a past board problem on civil engineering board exam. Okay, specifically sa structural engineering and construction. So this problem here, as you can see in the screen, is all about steel design, the welded bracket steel connection. Okay, so this is the specific problem that we'll be solving here. And grab your calculator and let's solve this thoroughly. Okay, so we have here a bracket that is welded on a steel column as shown. No? So dimensions here are given and the load P is also given. So the allowable weld shear stress on this weld given that. So the problems here is to calculate the force on each per mm of the weld given at these conditions when A is 0. Dito, for number 2, we are required to calculate the resultant load, the maximum resultant load on the weld. It will be considering the eccentricity dito, no? So basically, this A is our eccentricity from the weld. Okay? And for number 3, we are required to calculate the weld thickness. If the maximum resultant load in the weld is 750 newtons per millimeter. Okay? So this is a board exam problem and you can see this one on the CE reference volume 4 by Engineer Gilisanya. Okay? If you haven't have that book yet, you can purchase that one and look for the Gilisanya Engineering Review and Training Center Facebook page. Okay? Okay. So first, we want to calculate the maximum or the load in each weld when A is 0. So that means when A is 0, this P is directly acting at this line of the weld. So yung P natin will be evenly distributed on each mm of the weld, per mm of the weld, no? So we'll be solving this one using the MathCAD software. So by the way, ito yung ating three-dimensional view of this column, no? You cannot imagine this well here. This is supposed to be our front view of this column, no? We have here the bracket in this figure, and this is the side view. Okay, so again, we'll be using the MathCAD software here. Parang live solution tayo dito. Okay, all right, so we have here the givens. I just defined the givens here in MathCAD, and by the way, MathCAD can solve auto-generated units here, no? May mga units dyan, then the calculations here will be auto-generated. Okay, let's say this is our part 1. For part 1, when A is 0, so again, yung P natin will be directly, our P will be directly at the line of the weld. So we can say that, let's say that is the direct load. Define ko na lang siya dito, direct load. Direct load P, PD. Let's say PD, no? Direct load. Okay, so yung direct load PD natin, I must say that the PD is equivalent to the load P, divide natin siya sa total length of the weld, no? What would be the total length of the weld here? So that would be, take note that this one is B, so another B here. So that means the total length of the weld is twice of B, no? Evenly distributed siya because yung A is 0. Okay, walang eccentricity. Okay, so diretso na tayo dito. I will just change the unit. That would be in newtons per millimeter. Again, MathCAD can generate the units here automatically if we define the units here in the givens. Okay, so this is the answer for part 1. That is very easy. All right. How about part 2? Calculate the maximum resultant load in the weld newtons per millimeter due to eccentric load P. So, we'll be considering na the eccentricity, no? Take note, if yung P natin will not directly act to the centroid of the weld group, we should account the torsional moment or the bending moment alone dito, no? Now, try to imagine this one. Because of this load P here, it will create a moment. And by the way, ito yung P natin, the PD will be basically will be focusing on the critical portion of the weld here, no? So yung critical portion of the weld in this case would be at the farthest distance from the centroid of this weld group, no? So this is our PD, and ito yung suppose look at this dimension. So the centroid of this weld group will be needing that, no? Yung centroid of this weld group, basically that would be at half of this dimension because they are symmetrically distributed, no? Or symmetrically fabricated yung ating welds dito. So andyan yan, sa gitna yan, diretso. Okay? So yung because of this P, it will create a bending moment about this neutral axis natin, no? And we call that M. No? If we are to look at this one here in this plane, we can call that a bending moment. Now, if we are to look at this plane here, ito yung mangyayari. So this bending moment is similar to the torsional moment. No, yung plane view natin, that would be in this plane, that would be the torsional moment. Okay? Now, look at this one. Just like the bending stress formula, imagine this one. The maximum bending stress, consider only the weld group, would be at the farthest distance of the weld group. So from here, the farthest distance from the neutral axis would be here at this portion. Okay? Or the same dito. So this both point is critical and they will induce the same stresses. Okay? So the question here is the maximum resultant load. Take note, PD is always there, no? Now, para makuha natin yung maximum resultant load, we should account the maximum bending stress due to this eccentricity or due to this moment. So, it will be like this one. And denote natin siya as PSAD TX. Okay? And the maximum resultant load on that weld should be the resultant of these two. Okay? So, we can solve this one using the bending stress formula or pwede rin yung torsional stress, no? Common sa ating mga reviewers. Reviewer books. Okay, let's try that one. Okay. Part 2. So, what formula would be using? Okay, let me just scroll up. Para makuha natin yung PTX, diba we have the formula of bending stress F sub B is equivalent to My or for maximum MC over I. Okay? And again, yung I natin dyan would be per mm. Okay? So, gusto natin kunin yung PTX in terms of force, dapat yung I natin is per mm or per square mm. Basically, yung PTX natin using that bending stress formula, PTX is equivalent to M generalize muna natin My over I. Now, ano yung magiging I natin dito? Ano yung magiging inertia? Okay, ito yung formula natin to calculate the PTX. So, yung inertia natin dito, we are considering per mm of the inertia of this weld group. So, focus, let's see this figure. Ito, this portion. Tingnan natin yung portion na ito. So, basically, we'll be just considering the inertia of this weld group per millimeter. No? So, yung inertia natin dito should be, ano yung formula nga ng inertia? General. Let me just, for rectangular, that would be BD cube over 12. This is the general, no? General formula for inertia. Now, in this case, yung ating B dito, that should be assumed to be per mm. So, tatanggalin na lang natin yung B dyan. So, ang mangyayari, yung D natin dyan, that would be the this B dito, no? Itong B natin dito. So, basically, our inertia to be used here is equivalent to, again, tatanggalin natin because we are considering per mm. So, that would be B cube, no, B cube over 12. No? Again, don't misinterpret the, what we call this, the variables dito. B dito denote the base. So, basically, yung base natin kasi magiging per mm ng ating weld. No? Yung D natin here, yung D natin is yung depth of the considered weld. Ito, yung depth natin dyan is yung B. I hope that is clear, no? And take note that dalawa yan, multiply pa natin yan by 2. And that is, gawin natin siyang, kasi per mm yan, that would be in mm cube. Okay? Mas maganda siguro gawin natin scientific. Okay? 2.083 times 10 raised to 7 mm cube. Again, mm cube yung labas dyan because per mm yung consideration natin sa ating welds. Okay, now define muna natin yung moment. No? Yung moment natin dyan is equivalent to, klarong-klaro, the torsional moment or the bending moment here, that would be P times A. No? So that will be B times A, and that is, gawin natin newtons millimeter. Alright? Let me just do the scientific. 7.2 times 10 raised to 7 newtons millimeter. Okay, now we can solve our PTX. No? Therefore, our PTX is equivalent to, copy this formula. Ano yung magiging Y by the way natin? Ang Y natin dyan, that would be the distance from the neutral axis to the critical point. So that is half of B. No, 0.5 of B. Let's say 0.5 of B. And divided by the inertia we have. Okay? Divide natin by the inertia, and this value should be in newtons per mm. That is 864. Now, as you can see, this value is in the choices. But that's not yet the answer, no? Okay, so yan yung tatandaan nyo sa board exam. Tingin nyo, may sagot na agad, huwag kayong paloko. Basahin nyo talaga yung question. Maximum resultant load, so that should be the resultant of the direct load PD and the PTX. Okay, so the maximum resultant load, denote natin siya as R. That is equivalent to square root of PD squared plus PTX. Alright. So we already calculated our PD here on part 1. It's here. Ito. No? So directly the resultant load here is equivalent to in newtons per mm. Per mm always yan because we're considering per mm on the weld, no? Because it will not be evenly distributed na pag may eccentricity na. Iba-iba yung forces on each distance here ng ating weld. So this is the answer. And that is letter D, no? Okay, part 3. If the maximum resultant load in the weld is 750 newtons per millimeter, what is the required weld thickness in mm? Okay, so we need to calculate the required weld thickness. So ano yung consideration natin dito? So dito natin magagamit yung allowable shear stress, no? FB sub W. So sometimes binibigay ito and sometimes may code provision ito, no? That is, if I'm not mistaken, that is 0.3 of FY, no? So just review that one. May code provision ito. parang nagbago dito sa NSCP 2015. So, check that on the book, no? Okay, part 3. So, consideration natin para makuha natin yung weld thickness, that would be the allowable weld shear stress should be always greater or equal to the actual shear stress ng ating weld. Ito talaga yung consideration natin, no? Now, we have here given the allowable weld shear stress. Ano yung FA natin? So, yung FA natin here, the actual shear stress would be equals to force, the resultant force on sa critical portion over the area, effective area of the weld. Per mm yan. Okay? Ano yung R natin dito? So yung R natin here, sinabi sa part 3, that would be 750 mm. So we'll not be using this R natin dito. We'll not be using that one. Okay? Instead, we'll be using ano yung binigay. So define natin, R to be used here is equivalent to 750 newtons per mm. Okay? So that would be the R to be used. Now, ano yung effective area natin? So yung AE natin, remember, that is 0.707 weld thickness. Now, remember that this is per mm. So, we're considering per mm. No? Nasa steel design natin ito, 0.707. Kung saan to galing, no? Because approximately yung cross-section ng ating weld is considered as triangle. Okay? So, check that na lang sa mga reviewers at books natin. Okay, per mm. So, basically, that would be W, that is in mm, times per mm, 1 mm, naka-squared yan, no? Kaya magiging area yan. Okay? So, ito, para mas simple tingnan, we can say that the FBW, BW is equivalent to FA is R. So, yung R natin here is 750, ito, divided by the area, 0.707, multiplied by the weld thickness, which is we want to calculate per mm. Okay, I hope that is clear. So, mas maganda, i-cross multiply natin yan para makuha natin yung weld thickness, required weld thickness. So, that would be, I'll just copy this one. Okay, so, replace ko yung ating W by FBW. So, basically, nagkapalit lang sila. Okay? Klaro? So, that would be W required is in mm. Okay. FBW. Ayan, gumana. Okay, that is 11 point. Okay. So, okay, para ma-exact yung unit natin. By the way, ito palang 1 mm natin is andito na yan. Per mm na siya sa ating R. No? So, dito, tatanggalin ko na lang siya dito para yung unit natin is ganyan na lang ilalagay natin. Basically, times 1 lang siya dyan, no? Dito rin. Para sakto yung unit natin. Okay, so in millimeters tayo. That is 11.407. So, if ito yung lalabas, ano yung magiging sagot mo? Ano yung magiging sagot natin sa choices? Okay daw. Sige, try. The choices have 11 and also 12. Take note that if we'll follow this inequality, pag i-follow natin yung inequality, ang lalabas dyan that the W should be greater or equals to 11.407 mm. No? So, sa choices, yung gagamitin natin, yung hindi liliit sa 11.407. So, that would be the 12 mm. Okay? that should not be the 11 mm. I hope that is clear. So we'll be using the 12 mm. Use 12 mm. All right. So that's it. I hope you understand the solution, no? So by the way, pwede nyo ring sabihin, sir, hindi ba pwede yung torsional formula, yung torsion formula? Pwede rin. And also will come up to this the same. 'Di ba? If you try to remember, may formula tayo ng PTX is equivalent to TX, TY. Pag tinignan nyo yung sa formula book natin or sa mga reviewers, meron ding PTY equivalent to T, torsion, X over J. No? Pwede yan, no? But we'll come up to the same. Ano yung magiging J natin? So yung J natin, if you try to look at the book, that is equivalent to the summation of L over 12. Sorry. L over 12. Just that is multiplied by L squared. No, L cubed over 12. If I am not if I am not wrong, no? No, L pala siya, then L squared. Ito yung nakikita natin. Over 12 plus X sub G plus Y sub G. So, we can use this formula, itong J na to, if on every weld line is wala siya sa centroid. So, yung torsion natin, titingnan natin siya dito. Pag nakatingin tayo dito, automatically yung ating weld group is nasa centroid niya. Ito, centroid siya automatic. Now, if tingnan nyo yung formula na to, TY over J, that is still the same, MY over I. Ang ginamit natin. Ito, MY over I. Ano yun? Ito, MC over I or MY over I. The same lang yan, no? So, basically, wala tayong PTY dyan because automatically yung ating weld group is on the centroid pag tiningnan natin siya in this plane. I hope that is clear. So, medyo ma-analyze talaga siya, no? But if you go deeper, talagang maiintindihan niyo yan. Okay? So, that's it. Thank you. Masyado ng mahaba, no? Thank you and I hope you learned something today.